Alright, so we're now recording. So this evening, I'm showing to you our laboratory experiment number 2 titled Logic Diagram Formulation. So these are the stated objectives that we have to follow. Number 1 is of course to experimentally determine the truth table of a gate. Remember in our previous laboratory experiment, we're already familiar with the truth tables of the NOT gate, or gate and gate, 'di ba? So nagawa na po natin 'yon. Pero this time, syempre, we'll be combining na yung mga fundamental logic gates natin to come up with a combinational circuit. Kaya kailangan matutunan din natin paano mag-formulate ng truth table when combining the fundamental logic gates. And then syempre, we'll be connecting the fundamental logic gates together. Ayan. So, kukonect na natin yung AND gate, sa OR gate, sa NOT gate, depending on the Boolean equation na ibibigay ko po sa inyo. And then we also have to verify the pin configuration of each fundamental logic gates. Remember, di ba, na-discuss na po natin in our experiment number 1, yung ibig sabihin ng 14 pins ng different gates like 7404, 08, and then 32. So alam na natin kung nasan yung VCC, yung ground, yung input and output terminals. So kailangan master po natin kung nasaan yung mga pins ng atin pong mga logic gates na ginagamit. And then gagawa po tayo ng different logical functions by using AND, OR, and then NOT gates. Yung second part is basically theory na sabi ko nga sa inyo, no need naman to put this one in your laboratory report. But for discussion, allow me to read through you the contents of the theory. So sabi dito, digital circuits are circuits which deals with signals restricted to the extreme limits of 0 and some full amount, referring to 0 and 1. So it stands in contrast to analog circuits in which signals are free to vary continuously between the limits imposed by power supply voltage and circuit resistances. So unlike for the digital, it's a matter of 0 and 1, pero yung mga values in between, kino-consider natin kapag analog circuit. These circuits find use in true or false logical operations and even in digital computation. The circuits make use of the IC, pag sinabing IC, that is integrated circuit, and then components. Such components are actually networks of interconnected components manufactured on a single wafer of semiconducting material. So, di ba nakita na natin yung IC, nakita natin yung coating na insulator, nakita natin yung part na nagkakandak ng electricity, and then alam natin na yung loob ng atin pong ICI transistors. So integrated circuits provide multitude of pre-engineered functions available at very low cost, benefiting students, hobbyists, and professional circuit designers alike. So in your case kasi, hindi na natin concern kung paano dinesign yung IC, diba? So ang concern lang natin is gamitin yung ICs na available na sa market. At sabi dito, very low cost. So affordable naman so far yung mga ICs na ginagamit po natin. And most integrated circuits provide the same functionality as discrete semiconductor circuits at higher levels of reliability and at a fraction of the cost. So syempre depending on the ICs, the higher the number of pins, 'di ba? The complexity of its functionality, syempre nagbabari din naman yung cost ng mga ICs na pwede po natin gamitin. Circuits will primarily use the CMOS technology, so which stands for complementary metal oxide semiconductor, as this form of IC design allows for a broad range of power supply voltage while maintaining generally low power consumption levels. Through the CMOS circuitry is susceptible to damage from the static electricity or the high voltages will puncture the insulating barriers in the MOSFET transistors. Modern CMOS ICs are far more tolerant of electrostatic discharge than the CMOS ICs of the past, reducing the risk of chip failure by mishandling. The proper handling of CMOS involves the use of anti-static foam for storage and transport of ICs and measures to prevent static charge from building up on your body, which is use of a grounding wrist strap or frequently touching a grounded object. Sa industry, minsan gumagamit pa ng wrist strap. And in some laboratory rooms, may mga available din na wrist strap. Yan. To prevent the static charge. Circuits using the TTL technology require a regulated power supply voltage of 5 volts and will not tolerate any substantial deviation from this voltage level. Any TTL circuits will be adequately labeled as such, and it will be expected that you realize its unique power supply requirements. So in building digital circuits using integrated circuit chips, it is highly recommended that you use a breadboard with power supply rail connections along the length. In your case, diba, so nakagamit na naman tayo ng proto board or ng breadboard. We also know kung nasaan yung positive and negative terminal ng ating breadboard. So these are sets of holes in the breadboard that are electrically common along the entire length of the board. So ibig sabihin, itong mga nakikita natin dito, they are interconnected with each other horizontally. And of course, you can also use the pins naman vertically. Yan. Alright. Connect one to the positive terminal of a battery or the power supply and the other to the negative terminal, and DC power will be available to any area of the breadboard via connection through short jumper wires. So as I have said to you, yung typical na ginagamit natin na input voltage is around 5 volts na ideal to use doon sa mga ICs natin, reference to their datasheet, para hindi masira yung mga ICs po natin. Yan, so naka-note lang dito na yung mga red color here. So these points are electrically common. Yan, technically. So ito po yung ating BCC. And then yung naka-blue naman, that is our ground, which are electrically common as well. With so many of these integrated circuits having reset, enable, and disable terminals, actually, pag pumunta tayo sa mga sequential circuit, doon nyo ma-appreciate yung purpose ng mga enable, reset, clock, disable signals at kapag nagko-code na tayo sa Verilog. For now, we're not yet too much concerned on this one. Needing to be maintained in a high or low state, not to mention the BDD or the BCC and the ground power terminals which require connection to the power supply, having both terminals of the power supply readily available for connection at any point along the board's length is very useful. So most breadboards available have this power supply rail holes but some do not. So depending pa din doon sa binili po natin na proto board. Pero yung mga nakikita ko naman sa inyo, most of the breadboards that you're using ay meron namang mga holes. Up until this point, illustrating circuits have been using a breadboard lacking this feature just to show how it isn't absolutely necessary. However, digital circuits seem to require more connections to the power supply than any other types of breadboard circuits, making this feature more than just a convenience. So ngayon naman, babalikan uli natin yung concept pertaining to the basic logic gates. One thing that we have to remember is the truth table. So di ba yung truth table natin is basically a tabular listing of the values of a function for all possible combinations of values on its arguments. Diba? So remember the formula that we are using. We have base raised to n, for which the base is the number system. In your case, 2. And the n there is the number of the variables. Kaya dun sa ating previous laboratory experiment, kapag not gate, diba, since ang atin pong variable is only 1, 2 raised to 1 will give us 2 possible combinations. Kaya 0 and 1 lang yung sa NOT gate. Pero pagdating natin sa AND gate at saka sa OR gate, we have 2 variables already. 2 raised to 2 will give us 4 possible combinations. Kaya dun sa truth table natin, meron tayong 0, 0, 0, 1, 1, 0, and 1, 1. So, 4 yung possible na input combinations natin. So, ito yung sinasabi ko kanina. So, basically, this is the truth table or the basic logical operations as I have said. And then, basically, what we have used here for the AND and the OR gate, we have input terminals X and Y, and then the output Z. Remember that the operation of the AND gate is multiplication, the operation of the OR gate is addition, and the operation of the NOT gate is negation. And we represent the AND gate using that or the period. Minsan gumagamit tayo ng asterisk. And then kapag OR gate naman, gumagamit tayo ng plus. And then by the way, for the AND gate, sometimes we also use parentheses. Kapag nakakita ka ng parentheses, ibig sabihin nun, we'll be multiplying the literals or the variable. And then for the NOT gate, the usual, we're using over var just like this one. Sometimes single quote or the prime or tilde. Yun po yung some of the symbols and even exclamation point. Kapag nakakita tayo ng ganun, ibig sabihin NOT gate po siya. And then bakit po ganito, Sir Caldo, yung sequence ng aking AND or at saka NOT gate sa first two columns? Ito. Kasi ito ay binary which is also convertible to decimal. So kapag kinonvert natin ito sa decimal, this is 0, 1, 2, 3. 0, 1, 2, 3, 0, 1. Yan. And then, aside from the truth table and even the operations that we're using for the AND or and then the NOT gate, we can also represent this in switches. Kapag nakakita ka ng switch in parallel, so that is OR gate. So meaning to say you have to put here the literal or the variable. And then we have, of course, the power supply and the voltage controlled or current dependent source. Ito po yun, which is represented by resistor na merong circle. And then kapag naman switches in series, so ibig sabihin magkatabi lang siya. Ayan. So this is for the AND gate. At kapag nakakita ka na normally closed switch, that is NOT gate. So kung ito ay normally closed switch, therefore ito ay mga normally open switches. So again, for the switches, kapag inputs po natin, the logic 1 is switch closed, logic 0 is switch open, and for the outputs, the logic 1 is light on, and logic 0 is light off. And then yung NOT uses a switch such that logic 1 is switch open and logic 0 is switch closed. Ayan, so going back, this time, binigyan ko na kayo ng equation in such a way na i-obtain natin yung truth table and the logic diagram. So as you can see here, ang binigay kong equation, we have output variable f which is equal to x plus y bar z. Yan. So as you can see here, obvious naman, meron tayong tatlong input variables. Diba? So remember our formula, base raised to n. So the base here is 2 raised to n, the number of input variables, which is 3. 2 raised to 3 will give us 8 possible combinations. Kaya ito, 1, 2, 3, 4, 5, 6, 7, 8. At kapag kinonvert mo ito, 0 to 7 po yan. Ngayon, Sir Caldo, paano ko po masusulat ng tama yung input combinations ng XYZ? Ang technique dyan, since 2 raised to 3 is equal to 8, yung 8, divide mo muna by 2. 8 divided by 2 will give us 4. So, ilista mo muna first 4, 0, followed by 4 na 1. Then 4 divided by 2 is 2. So yung first 2, 0, 1, 1, 0, 0, 1, 1. And yung dulo ay 0, 1, 0, 1, 0, 1, 0, 1. Para malis natin ng tama at sunod-sunod yung atin pong input combinations. And then as you can see here, sabi ko sa inyo, kapag nakakita ka ng plus, ibig sabihin nun, OR gate yon. Kapag nakakita ka ng overbar, ibig sabihin nun NOT gate. At kapag nakakita ka ng dalawang variable na magkatabi na walang alteration in between, it could be multiplication. So ibig sabihin, AND gate, ito ng Y bar at saka ng Z. Remember, yung representation ng NOT gate natin, we use this symbol. Kapag naman AND gate, we use this symbol. At kapag OR gate, yung plus, we use this symbol. Sometimes nilalagyan pa natin dito ng plus sa loob and then ito, tuldok sa loob para hindi tayo ma-confuse kung arin yung OR gate, kung ano yung AND gate. Kasi madali namang ma-distinguish yung inverter because of the nibble. Yan. So, paano ko po ipo-formulate yung truth table ngayon, Sir Caldo? So, isusulat mo sa output yung f is equal to x plus y bar times z. Basically, isa-substitute mo lang yung values ng x, y, z. So ito ay 0 plus 0 var times 0. So tingnan mo muna to 0 bar, in-invert mo yung 0, magiging 1 times 0, 0 plus 0, 0. Kaya naging 0 tong 0, 0, 0. Ito naman, Sir Calda, bakit naging 1? Kasi di ba ang value ng x ay 0 plus yung y bar natin, ang value ng y here is 0, in-invert magiging 1 times the value of z is 1. 1 times 1 is 1 plus 0 is 1. Kaya naging 1. And the rest is history. Palike naman kung clear po tayo doon sa ating truth table. Ayan, thank you. And then paano po yung ating logic diagram? For the logic diagram naman, basic lang din. Ang technique dyan, we can do horizontal or vertical. Etong technique na ginamit ko dito is vertical. Horizontal. Sinulat ko muna dito sa left side yung input literals, X, Y, and then Z. 'Di ba? Obviously dito, ang uunahin mo lagi yung inverter. 'Di ba yung Y naka-invert? So yung Y, lalagyan ko muna dito ng inverter symbol. Ang output na nito ay Y bar. Yung inversion ng Y, sabi dito, naka-AND sa Z. Kaya gagamit ako ng AND gate, connected yung Y bar dun sa Z. And then, naka-OR. Ibig sabihin yung X, papasok sa OR gate, and then naka-OR siya doon sa AND gate ng Y bar at saka ng Z. And then, ang resulting nating output ay F. Again, as you can see here, one input yung NOT gate, two inputs lang yung AND gate, at saka two inputs lang yung OR gate. Kasi yung ginagamit natin na IC ay one input NOT gate, two inputs AND gate, at saka two input OR gates. So, although sometimes, kapag lumaki na yung equation natin, pwede actually na tatlo yung paa nito, pati to, pwede maging 5 and so on. Pero for simplicity, just for now, two inputs lang lagi yung AND gate at saka yung OR gate. Palike o like kung clear yung pag-formulate ng logic diagram. Ayan, so pwede ko kayong bigyan ng equation, ibibigay mo sa akin yung truth table at saka logic diagram. Pwede rin it's the other way around. Bigyan kita ng logic diagram, ibigay mo equation, bigay mo yung truth table. At minsan truth table, give me the equation and the logic diagram. Pero if that's the case, kailangan natin gumamit ng Carnot map. At ituturo ko pa naman yun sa inyo in the long run. So Boolean equations, truth tables, logic diagrams, basically they describe the same function. Truth tables are unique expressions and logic diagrams are not. So this gives us flexibility in implementing the functions. Kaya nga ang keyword dyan, dapat alam mo yung truth tables ng NOT gate, AND gate, at saka OR gate. Kasi kapag familiar ka doon sa kanilang operations, hindi ka na malilito kahit papahirapan ko yung circuit na ibibigay core equation. So ito uli ay a short recap. In the 70 parallel series, yung 70 parallel 08, it provides us two input AND gates. As you can see, the pin connections are different. So ito po yung pin 14 again is the BZC for the 5 volts. And then yung pin 7 natin is the 0 volt for the ground. Again, yung inputs 1 and 2, these are for pins 1 and 2 for the inputs. Ang output niya ay 3. Diba? 4 and 5 inputs, ang output ay 6. 11, 13 and then 12 inputs, ang output ay 11. 10 and 9 inputs, ang output po ay 8. So, ibig sabihin yan guys, kapag kailangan ko ng maraming inputs and outputs ng O8, pwede ko namang gamitin yung ibang pins. In our initial experiment, ito lang yung ginamit mo. But you can actually use the other pins ng ating 7408. 70 parallel series devices usually require a regulated 5 volts power supply. The LM7805 and LM78L05 are suitable power supply regulator devices. In your case, nag-create naman kayo or may ginawa kayong sarili ninyong power supply. The 74HC08 is a pin-compatible replacement for the 74LS08 with improved electrical properties and a wider range of power supply voltage. So, pwede ka naman gumamit ng ibang IC actually for the AND gate, pero for simplicity, LS series yung ginagamit natin. Similarly, ganun din. For the hex NOT gates, pwede kang gumamit ng 7404, which is the one that we are using. Pero pwede ka rin gumamit ng 7405, 7414. May konting difference lang siya, like yung O5 is with open collector outputs, yung 1.4 ay with Schmidt trigger inputs. The 7414 has Schmidt trigger inputs that could provide good noise immunity. They are basically ideal for slowly changing or noisy signals. But then again, as you can see here, the pins for this different series ay pare-pareho lang, 'di ba? Pin 14 again is for the VCC, pin 7 again is for the ground, pins 1, 3, 5, 9, 11, 13, these are the input gates, and then the output gates are 2, 4, 6, 8, 10, and then 12. Yan. On top of that is you have to also understand how to create switching circuit. Yan. So dito binigyan ko kayo ng switching circuit. So as I have explained kanina, we have the power supply, the voltage current dependent source, and we have here the values. Then alam natin kung ano dyan yung normally open and then the normally closed. And then as you know, 'di ba, yung series, ito po ay AND gate. And then in parallel yung kanilang series connection doon sa D. And then yung parallel connection nitong dalawa ay naka-series doon sa A. So yun lang naman yung kailangan nating tandaan. So therefore, pwede na nating makuha yung value ng L. Ibig sabihin, we're obtaining the equation for variables A, B, C, and then D. So this is basically useful model for the relay circuits and for CMOS gate circuits, which is basically the foundation of the current digital logic technology. So in doing so, we can obtain this expression, 'di ba, or equation. Sabi ko kanina, yung B ay naka series sa C naught, kaya B times C naught. And then yung series connection niya ay naka-parallel sa D, kaya naglagay dito ng plus D. And then enclose ulit natin ang parenthesis kasi nga yung kanilang parallel connection is naka-series naman sa variable A. And then, as you know, distributive method, di ba? Algebra, basic algebra. So, pwede mo siyang i-distribute magiging ABC naught plus AD. Or you can further factor out A there, di ba? To give us BC naught plus D. Yan. Ito rin yung in-explain ko kanina. And then, naglagay lang din ako dito ng notes para hindi tayo malito. In a circuit diagram, the symbol with one long and one short parallel lines represents a direct current or the DC power source, such as battery or the cell. In your case, the power supply or the 9 volts battery that you're using. The longer line represents the positive terminal, while the shorter or the often thicker line represents the negative terminal. In a circuit schematic as well, a resistor enclosed in a circle usually denotes a dependent or controlled voltage or current source, and the specific symbol is typically drawn as a resistor inside a solid circle, indicating that the resistance or the power output is actively controlled by another variable, like the voltage or the current elsewhere in the circuit. So as we perform the experiment, these are the materials needed. Again, we have to use 9 volts battery or regulated power supply set, say for example to 5 volts. You have to use your breadboard. Siguro mga dalawang AND gate ICs kasi depende dun sa equation na gagawin po natin just to be sure. Pero minsan kasya naman yung isang AND gate. Dalawang OR gate ICs and also dalawang NOT gate ICs natin. And then 5 LEDs, connecting wires, Arduino wires, wire stripper, and then cutter. Yan. So nakalagay dito yung procedure that you're going to do. Siyempre yung unang step natin, you have to make team assessment on the availability of the materials or components to be used. That's very basic and important. Naka-group naman kayo, make sure na you have your enough materials sa ating laboratory experiment. And then in our case, we don't have laboratory technician for us to provide the available insufficient materials or components. Then review uli nyo yung truth tables and pin configurations ng fundamental logic gates and then not, and provide yung logic diagram for each as proved by the truth tables. Based on the experiment, you also have to provide the pin configuration for the logic gates and combine each logic gate so that we could form the three Boolean equations as shown below. Provide its truth tables, logic diagram, and pin configuration, and then plot them on the breadboard and seek for my approval. Ang unang gagawin nyo as we perform the experiment yung equation 1. Again, given na yung equation 1, di ba? Yung f is equal to x plus y bar z. Ito rin yung given ko kanina dito sa taas. That's the same. So, ibig sabihin, available na yung equation, truth table, logic diagram. Ang gagawin mo na lang yung switching circuit. This one. Yan. So, available na po siya. Then, kapag nagawa mo na siya, ipa-plot mo na siya sa breadboard. Once okay na yun, na-approve ko na, that's the time gagawin mo yung second equation, which is f is equal to wz plus yz naught plus w bar x bar y. Again, as you can see here, ito, tatlo yung inputs, kaya we have 8 possible combinations. Ito, we have w, x, y, z. So, we have 4 inputs, kaya nag-expect tayo ng 16 possible combinations. Equation 3 is medyo madami, 'di ba? So, I think 5. 2 raised to 5 na po ito. Pero for now, ang gagawin lang natin on Sunday is equation 1 and 2. So hanggang doon lang muna tayo kasi depende on your ability. Kapag masyadong mabilis po tayo, we can go with equation number 3. So ang ilalagay uli natin doon sa ating yellow paper is of course your group number, 'di ba? The leader, the members of the group, then isulat mo equation 1, letter A, truth table, letter B, logic diagram, switching circuit, then actual breadboard plot. Itong pin configuration with breadboard tracing, ituturo ko muna sa inyo. Normal ang gusto ko dito, idodrawing mo talaga yung breadboard. Then ilalagay mo yung pin connections niya para clearly understood sa'yo kung paano mo siya kinonect doon sa breadboard. Pero for now, wag muna natin siyang gawin. And kapag nagawa mo na yon, na-check ko na siya, gagawin mo na rin yung equation number 2. Same lang din, A, B, C, D lang po ulit tayo. Hindi na po kasama yung pin configuration with breadboard tracing. And then again, conclusion. So based on the fundamental logic gates experiment, what were you able to verify? What were you able to prove? You can also provide an elaborative and detailed explanation of the theories involved which you deem to be most important. Again, wag natin kalimutan to take pictures doon sa sample sa truth table na isang iilaw at isang hindi iilaw as evidence na nagawa po natin yung laboratory experiment number 2. Thank you very much.